Hi, I'm Gary Ritchie for Pharmaceutical Manufacturing Magazine. I'm here today at Pittcon 2009 with Dr. Mike Doyle of Symbion Systems Incorporated. Mike, it's good to see you.
Very, very nice seeing you.
Tell us about the Symbion suite of software.
Well, the Symbion suite has been developed with a particular mission in mind. And that mission was to provide a software package that would provide all of the capabilities required to do process automation, while at the same time being able to communicate with virtually any analytical instrument, any chemometrics package, any process historian, distributed control systems, virtually any type of software that you would want to communicate with, and at the same time provide full automation capability, full laboratory instrument control capability. And the Symbion, in a sense, acts as an executive. We control a lot of different things and provide the menus and the programming environment to make all these things work together smoothly. So that
from a, regulatory perspective, the pharmaceutical industry would be interested, and probably is interested, in having a central software package that could do functions in development, in research, and I guess in scale-up.
Yes.
So how do you accomplish each of these things in which the PAT guideline actually lays this out very succinctly in the guideline?
You have different types of environments that are required to do all the range of activities that various customers would want. Let's say if you're in chemical development, you basically want a fairly open ability to control an instrument, and in your laboratory make the instrument do anything you want. So that in a sense is one of the functions of Symbion, to provide that universal instrument control capability, which enables you to control, let's say...
Key phrase there, universal instrument capability.
Right.
Some of the things that go on in development may not be some of the things that you need to do later on in full scale-up.
Yes.
For instance, the level of data acquisition that you might want to take in the beginning will certainly be a lot wider and a lot more as you're understanding how you're what you're controlling.
That's correct.
Later on, you want to be able to tailor your software to meet your demands.
For example,
how do you?
Well, for example, in the laboratory, you very often want to look at a lot of different things and take a quick look, maybe look at mixtures of chemicals in 3-dimension, identify things that are happening within a reaction. Usually you don't want to do a full-scale calibration at that point. You simply want to monitor changes like that and try to get a feeling for how to proceed. Now when you reach the next stage where you've, let's say, configured a reaction, you know what you want to do, and you now want to let's say, build that into a full process configuration or a process method. Now you move on to the next phase of Symbion, which is a process development capability. And at that point, you can use a series of pull-down menus. You can use some visual wizards that we have to enable you to decide you want to connect a given spectrometer into a control script that tells that spectrometer exactly how to operate. You then take the spectra, or if, assuming it's a spectrometer, not a chromatograph, take the spectrum from that spectrometer, route it to a chemometrics package, to a runtime module of chemometrics packages. And that could be any of the popular chemometrics package. Pirouette, PLS Toolbox, Unscrambler, any of those.
And those interfaces, I guess not every one of them, is as far as my knowledge, is 21 CFR Part 11 compliant.
Yes.
And so Symbion you wouldn't have to do more qualifications on Symbion if you're just using it as an interface or a controller for some of these other.
That's correct.
Okay. What are some of the applications and projects that you actually have this deployed at? And can you talk about any of those?
Well, some we can and some we can't. It's deployed in pharmaceuticals, in the paper industry, in petrochemicals, in analyzing wastewater in large chemical plants. And that's perhaps a typical type of application. For example, in a wastewater system, for example, you need to turn on a pump to pump a sample from a master drain in the plant. So you pump a sample into the wastewater system, you valve it into a vessel. So we've got several valves that we have to control at that point. We turn on a sparging pump, which directs an airflow through the vessel, route the output to a gas cell for analysis, analyze it by an FTIR spectrometer, take that result, send it to a chemometrics package to analyze the concentration of several different components, and then those concentrations get routed to a historian, and of course there are also alarms. If there's a spill of some particular chemical or a combination of chemicals, an alarm is sent back to the control room or to the operator's home if that's necessary. Because this thing runs 24 hours a day, non-stop, and most of the time there isn't an operator there watching the instrument. So we communicate remotely with any location, remote or local,